Hey my dear little charms, welcome to 90 Plus My Tuition app. See friends, here is my old cycle. I just kept it outside. Can you see any changes in the cycle? See, rust is formed on the cycle. How it became rust so fast? I'll tell you. It is because when we keep this cycle exposed to humid atmosphere for a longer period of time and the ion on the cycle react with the atmospheric oxygen to form hydrated iron oxide or rust. As a result, the nature and identity of the initial substance, that is iron, will get changes. And I'll give you some more daily life situations. That is, milk is left at room temperature during summers. We know that milk will convert into curd, right? And food is cooked. We know after cooking food, the nature of the initial substance, that is vegetables, will change, right? The third situation is fermentation of grapes. As a result of fermentation, we will get wine and digestion of food in our body. As a result of digestion, we will get energy. In the case of respiration also, we will get energy. All these changes are referred to as chemical changes. So you tell me, what do you mean by chemical changes? Yes, chemical changes are the changes of a material into another one as a result of new material being formed with different properties. All these situations, the nature and identity of the initial substance have somewhat changed. So, whenever a chemical change happens, we can say that a chemical reaction has taken place. So, friends, here we start our first chapter, Chemical Reactions and Equations. So you tell me, what do you mean by chemical reactions? Yes, chemical reaction is a process in which one or more substances called reactants are converted into different substances called products and which has different physical and chemical properties. Okay, now let's do some activities. Here is 2 cm long of magnesium ribbon. Now let's rub this magnesium ribbon using a sandpaper. Okay, why am I using sandpaper here? That is, when magnesium ribbon is exposed to atmospheric oxygen for a long, it forms a layer of magnesium oxide over the magnesium ribbon, and which lowers the reactivity of magnesium ribbon. That's why before performing this experiment, we are rubbing the magnesium ribbon using a sandpaper. Now let's hold this clean magnesium ribbon using a pair of tongs. Now let's burn this magnesium ribbon using a burner. What do you observe? See, this magnesium ribbon burns with a dazzling white flame and changes into a white powder. This white powder is magnesium oxide. How did it form? We can say that this magnesium oxide is formed due to the reaction between magnesium and oxygen present in the air. So we can represent it as magnesium plus oxygen gives magnesium oxide. So friends, let's conduct another activity. For that, let's take a test tube here. To this test tube, we can add lead nitrate solution. To this lead nitrate solution, we can add potassium iodide solution. What do you observe? Wow! Can you see this yellow colored substance formed inside the test tube? What is this yellow colored substance? Yes, it is lead iodide, which is insoluble in water. and the reaction is PbNO3 twice plus 2Ki gives 2KNO3 plus PbI2. Friends, do you notice something? Here, both lead nitrate and potassium iodide are colorless. But when it mixed together, we got yellow color substance, right? Which characteristics of chemical reaction do you observe in this activity? Yes, it is change in color. So friends, let's do the next activity. For that, I have taken few zinc granules in a conical flask. To this, we can add dilute sulfuric acid. What do you observe? Oh, liberation of gas is formed inside the conical flask. What do you think? Which gas is liberating? Yes, the liberating gas is hydrogen. When zinc granules react with dilute sulfuric acid, zinc sulfate and hydrogen gas is formed. And here we can see the liberation of heat inside the conical flask. And the reaction is Zn plus H2SO4 gives ZnSO4 plus H2. We can see two characteristics of chemical reactions in this activity. That is evolution of a gas and change in temperature. From these three activities, we can conclude that if a chemical reaction is taking place, we can observe any of these changes. That is change in state, change in color, evolution of a gas and change in temperature. When we monitor the changes around us, we can see that a wide range of chemical reactions are taking place around us. So in this chapter, we will look at the different varieties of chemical reactions and how they are represented symbolically. So friends, let's start our chapter. We have already seen that when magnesium ribbon is burned in oxygen, it gets converted into magnesium oxide, and it can be written as magnesium plus oxygen gives magnesium oxide. This equation we can call as word equation. Now let's discuss chemical equations in detail. Here the left hand side or LHS contains magnesium and oxygen, right? Yes, they are called reactants. On the right hand side or RHS, the newly formed substance is magnesium oxide, which is called products, and this is known as word equation. Through the use of an arrow, a word equation depicts the transformation of a reactants into products, and the reactants are written on the left hand side or LHS with a plus sign between them. Similarly, the products are written on the right hand side or RHS with a plus sign between them. The arrowhead indicates the reaction's direction by pointing towards the products. Is there any other shorter way for representing chemical equations? Yes, when we use chemical formulae instead of words, we can construct chemical equations more simple and informative. A chemical reaction is depicted by a chemical equation. Therefore, we can write the word equation as Mg plus O2 gives MgO. Is the number of atoms of each element is same on both sides? No, because the left hand side contains 2 oxygen atoms, whereas the right hand side contains only 1 oxygen atom. What about magnesium? We can say that it is equal in number on both the sides. Therefore, we can say that this equation is not a balanced one. This is an unbalanced equation because the mass is not same on both the sides. Such equations is known as skeletal chemical equation for a reaction. And we know that this chemical equation represents the burning of magnesium in the air. So you tell me, what is law of conservation of mass? It can be stated that mass can neither be created nor destroyed in a chemical reaction. That is, total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. Or we can also say that number of atoms of each element remains the same before and after the chemical reaction. Now let us learn balancing a chemical equations step by step. For that, let's consider this equation. That is, Fe plus H2O gives Fe3O4 plus H2. So you tell me, is this a balanced one? No, right? We can say that the number of atoms on both sides are not equal. So this is not a balanced equation. This is an unbalanced equation. So let's balance this chemical equation. Are you ready? Alright. First, we can draw boxes around each formula. You keep in mind that you should not change anything inside the boxes while balancing the equations. Now, let's list out the number of atoms of different elements present in the unbalanced equation. Here you can see there is only one ion is present on the LHS, whereas 3 ions are present on the RHS. In the case of hydrogen, we can see that both LHS and RHS contains 2 hydrogen atoms. What about oxygen? We can say that LHS contain only 1 oxygen, whereas RHS contain 4 oxygen atoms. We can start balancing with the compound that contains the maximum number of atoms. It may be reactant or product. Here you can see there are 4 oxygen atoms in the RHS, whereas only 1 oxygen atom in the LHS, right? To equalize the oxygen atoms, you keep in mind that we cannot alter the formulae of the compounds or elements involved in the reaction. So you tell me, to balance oxygen atoms, what we should do? Yes, we can put coefficient 4 as 4H2O. So the partially balanced equation becomes Fe plus 4H2O gives Fe3O4 plus H2. Now we have 8 hydrogen atom and 4 oxygen atom on the left hand side. Now we can say that the oxygen atom is balanced because both LHS and RHS contains 4 oxygen atoms. Now iron and hydrogen atoms are still not balanced, right? Let us balance hydrogen atoms in the partially balanced equation. Here you can see there is 8 hydrogen in the LHS, whereas RHS contains only 2 hydrogen atoms. To balance the hydrogen atoms, we can make the number of molecules of hydrogen as 4 on the RHS. So the partially balanced equation will be Fe plus 4H2O gives Fe3O4 plus 4H2. Here we can see both LHS and RHS contains 8 hydrogen atoms, so the hydrogen atoms are balanced. Now let us pick up the third element which is not balanced. It is iron. So here you can see there is only 1 iron in the LHS, whereas RHS contains 3 iron. To balance this, we can put coefficient 3 as 3Fe on LHS. So the partially balanced equation becomes 3Fe plus 4H2O gives Fe3O4 plus 4H2. Finally, to check the correctness of the balanced equation, we can count the atoms of each element on both sides of the equation. Here you can see LHS and RHS contain 3 iron atoms. In the case of hydrogen, we can see LHS contains 8 hydrogen and RHS contains 8 hydrogen. What about oxygen? We can see that both LHS and RHS contain 4 oxygen atoms. So we can say that this is a balanced equation. This method of balancing chemical equations is known as hit and trial method, which means we make trials to balance the equations using smallest whole number coefficient. Does this equation tell us anything about the physical states of each reactant and product? No information has been given in this equation about their physical states, right? To make chemical equations more informative, the physical states of reactants and products are mentioned along with their chemical formulae. For that, we can use the notations small g for gaseous, small l for liquids, small s for solids and aq for aqueous. So our balanced equation can be written as 3Fe solid plus 4H2O gaseous gives Fe3O for solid plus 4H2 gaseous. Have you noticed one thing? Here the symbol G is indicated with water. It is because here water is used in the form of steam. Usually physical states are not added along with the chemical formulae unless it is necessary. Sometimes we may add the reaction conditions such as temperature, pressure, catalyst, etc., which may be indicated above or below the arrow in the equation. For example, CO gas plus 2H2 gas at 340 atm gives CH3OH liquid and 6 CO2 aqueous plus 12 H2O liquid in the presence of sunlight and chlorophyll gives C6H12O6 aqueous, that is glucose, plus 6O2 aqueous plus 6H2O liquid. Now let's try to balance this equation, that is Mg plus O2 gives MgO. So you tell me how many magnesium is present on LHS? Yes, there is only one magnesium is present on the LHS. And what about RHS? We can see there is also one magnesium is present in the RHS, which means in this equation magnesium is balanced. And what about oxygen? Here we can see 2 oxygen atoms is present on the LHS, whereas only 1 oxygen is present in the RHS, which means in this equation oxygen atom is not balanced. To balance oxygen atoms, we can put coefficient 2 on the RHS. So the partially balanced equation becomes Mg plus O2 gives 2 MgO. Now you tell me, is this a balanced one right now? Now we have 2 oxygen and 2 magnesium on the right hand side, but in the left hand side only 1 magnesium is present. Therefore, we can put a coefficient 2 on the left hand side as 2 magnesium. So we have 2 Mg plus O2 gives 2 MgO. Here we can see both left hand side and right hand side contain the same number of magnesium. Also, the number of oxygen on the left hand side and right hand side are also same. So we can say that this equation is a balanced one. Here is another equation, that is Zn plus H2SO4 gives ZnSO4 plus H2. Now you tell me whether this equation is balanced or not. Now you just observe this equation carefully and tell me how many zinc is present in the left hand side. Yes, 1 zinc is present in the left hand side. Also we can see RHS has 1 atom of zinc. So we can say that zinc is balanced in this equation. Now let's check how many hydrogens are present in the left hand side. Here you can see there is 2 hydrogens is present in the left hand side, and we can see that RHS also has 2 hydrogen atoms. So we can say in this equation, hydrogen is also balanced. What about the sulfur atom? Here we can see that both LHS and RHS contain 1 sulfur each, which means sulfur atom is also balanced in this equation. The last element is oxygen. Here also both LHS and RHS contain equal number of oxygen atoms, that is 4. Since both the sides, that is LHS and RHS, contain equal number of atoms of each element, we can conclude that this equation is a balanced chemical equation. So friends, let's try to balance one more equation, that is Al plus O2 gives Al2O3. Here we can see left hand side contain only 1 aluminium, whereas right hand side has 2 aluminium atoms. In the case of oxygen also, right hand side contain 3 oxygen atoms, whereas left hand side contain only 2 oxygen atoms. In order to balance this equation, we can put coefficient 2 as 2Al2O3. So the equation becomes Al plus O2 gives 2Al2O3. Now we have 4 aluminium and 6 oxygen atoms. So we can say that we have to change the left hand side also. For that, we can put coefficient 3 as 3O2 and 4 as 4 aluminium. Therefore, the equation becomes 4Al plus 3O2 gives 2Al2O3. Therefore, from this table, we can see that both left hand side and right hand side contain equal number of atoms. Therefore, this equation is a balanced one. Now let's discuss some questions. First question is, why should a magnesium ribbon be cleaned before burning in air? We know that magnesium is a very reactive metal. When we keep the magnesium in the open air, it can react with the gases present in the air, and cleaning will remove those impurities formed due to the reaction of magnesium with air. Our second question is, write the balance equation for the following chemical reactions. First reaction is hydrogen plus chlorine gives hydrogen chloride, and the second reaction is barium chloride plus aluminum sulfate gives barium sulfate plus aluminum chloride, and the third one is sodium plus water gives sodium hydroxide plus hydrogen. So friends, let's write the balanced chemical equation. For that, let's consider the first reaction, that is hydrogen plus chlorine gives hydrogen chloride. For that, first we can rewrite the chemical equation as H2 plus Cl2 gives HCl. On balancing this equation, we will get H2 plus Cl2 gives 2HCl. The second reaction is barium chloride plus aluminum sulfate gives barium sulfate plus aluminum chloride. Now let's rewrite the paired equation as chemical equation, that is BaCl2 plus Al2SO4 thrice gives BaSO4 plus AlCl3. On balancing, we will get 3BaCl2 plus Al2SO4 thrice gives 3BaSO4 plus 2AlCl3. The third reaction is sodium plus water gives sodium hydroxide plus hydrogen. So tell me, how can we write the chemical equation for this word equation? Yes, Na plus H2O gives NaOH plus H2. On balancing, we will get 2Na plus 2H2O gives 2NaOH plus H2. Our next question is, write a balanced chemical equation with state symbols for the following reactions. First reaction is solutions of barium chloride and sodium sulfate in water react to give insoluble barium sulfate and solution of sodium chloride. And the second reaction is sodium hydroxide solution in water react with hydrochloric acid solution in water to produce sodium chloride solution and water. So friends, are you ready to answer this question? Alright, let's consider the first reaction, that is solutions of barium chloride and sodium sulfate in water react to give insoluble barium sulfate and solution of sodium chloride. So we can write the chemical equation of this reaction as BaCl2 plus Na2SO4 gives BaSO4 plus NaCl. On balancing this equation, we will get BaCl2 plus Na2SO4 gives BaSO4 plus 2NaCl, and we can state the symbols of the reactants and products involved in this reaction. So we will get BaCl2 aqueous plus Na2SO4 aqueous gives BaSO4 solid plus 2NaCl liquid. Now let's consider the second reaction, that is sodium hydroxide solution in water react with hydrochloric acid solution in water to produce sodium chloride solution and water. Now we can write the chemical equation of this reaction, that is NaOH plus HCl gives NaCl plus H2O. Now we can state the symbols of the reactants and products involved in this reaction. So we can write it as NaOH aqueous plus HCl aqueous gives NaCl liquid plus H2O liquid. So friends, let's move on to our next topic, that is types of chemical reactions. We know that at the time of a chemical reaction, atoms of one element do not change into those of another element. Also, we can say that during a chemical reaction, both breaking and making of bonds between atoms produce new substances. So friends, in this section, we will study the types of chemical reactions. First type of chemical reaction is combination reactions. For that, let's do an activity. Here I have a beaker. To this beaker, let's add calcium oxide. So friends, calcium oxide is also called as quicklime. Now let's add water slowly to this beaker. What do you observe? Yes, calcium oxide reacts vigorously with water and produces slaked lime or calcium hydroxide. Also, we can see that a large amount of heat has evolved from the beaker. So tell me, what would be the chemical reaction behind this? Here is the chemical reaction. Here you can see CaO plus H2O gives CaOH twice. Here we can say that the CaO is called quicklime and the newly formed CaOH twice is called the slaked lime. And here we can see that the calcium oxide and water react to form only one product, that is slaked lime or CaOH twice. Such reactions in which a single product is formed from two or more reactants is called combination reaction. So friends, this slaked lime is used for whitewashing walls. How does it work? We can say that calcium hydroxide reacts with the carbon dioxide present in the air to form calcium carbonate, and which form a layer on the walls. But this is formed only after 2 or 3 days of whitewashing, and this is responsible for the shiny finish of walls. And here you can see the chemical reaction, that is CaOH twice plus CO2 gives CaCO3 plus H2O. That is calcium hydroxide on reaction with carbon dioxide to form calcium carbonate and water. Now, let me ask you a question. What is the chemical formula of marble? Yes, it is similar to that of calcium carbonate, that is CaCO3. And here are some more examples of combination reaction. First one is burning of coal, and the reaction is C plus O2 gives CO2. Here you can see carbon on reaction with oxygen to form carbon dioxide gas. Another example is formation of water from H2 and O2, and here you can see the chemical reaction. 2H2 plus O2 gives 2H2O. Here both hydrogen and oxygen are gases and the newly formed water is liquid. So you tell me, what do you mean by combination reactions? We can say that when two or more substances, which may be elements or compounds, combine to form a single product, such reactions are called combination reactions. So we can also say that formation of magnesium oxide from magnesium and oxygen is also an example for combination reaction. That is, magnesium and oxygen react to form a single product, that is magnesium oxide. And here you can see the chemical reaction. That is 2Mg plus O2 gives 2MgO. During the preparation of slaked lime, we have seen that a large amount of heat was evolved, right? Such chemical reactions are called exothermic chemical reactions. So you tell me, what do you mean by exothermic chemical reactions? We can say that the reactions in which heat is released along with the formation of products are called exothermic chemical reactions. So, can you give me one example of an exothermic chemical reaction? Yes, burning of natural gas is an example for exothermic chemical reaction. And here you can see the chemical reaction. That is, CH4 plus 2O2 gives CO2 plus 2H2O. Here we can see that natural gas, that is methane, on reaction with oxygen, we will get CO2 and 2 molecules of water. Friends, do you know respiration is also an exothermic process? We know that respiration is extremely important to our body. Now let me ask you a question. Are breathing and respiration is the same thing? I know you must be saying yes, but it is not true. So, first let us understand what exactly the difference between breathing and respiration. Before answering this question, can you tell me where we get the energy to perform all the activities? Yes, food is correct, but it is not completely correct. We can say that food is a source of energy, which means energy is stored inside the food. To unlock the energy from the food, we need to be broken down, and this requires oxygen. So we can say that the process in which food is broken down in the cell with the help of oxygen to release energy is called respiration. For example, rice, potatoes and bread contain carbohydrates, and these carbohydrates are broken down and it forms glucose, and this glucose combined with oxygen in the cell of our body and provides energy. And here you can see the chemical reaction. That is C6H12O6, which is a glucose, on reaction with 6O2 gives 6CO2 plus 6H2O plus energy. So you tell me how respiration becomes different from breathing? Well, breathing does not involve breakdown of food molecules inside the cell. In fact, breathing is purely an exchange of gases, that is oxygen and carbon dioxide, whereas deriving energy from food molecules with the help of oxygen is called respiration. Here is one more example of exothermic reaction, that is decomposition of vegetables into compost. Now you tell me one example that heat is given out along with the formation of a single product. Yes, 2 Mg plus O2 gives 2 MgO. That is the formation of magnesium oxide from magnesium and oxygen is an example of exothermic combination reaction. Now we can discuss the second type of chemical reactions, that is decomposition reaction. Before that, let's do an activity. Here I have 2 grams of ferrous sulfate crystal in a dry boiling tube. So you tell me, what is the color of ferrous sulfate crystals? Yes, it is green in color. Now let's heat this ferrous sulfate crystals. What do you observe? Yes, the color has changed. It has changed into a reddish brown color, right? Also, I can feel a smell somewhat similar to burning of sulfur. Why did this color change happen here? Any idea? We can say that when I heat the ferrous sulfate crystals, it is converted into ferric oxide. Interesting fact is that the ferrous sulfate crystals is green in color, whereas the ferric oxide has reddish brown color. And here you can see the chemical reaction, that is 2 FeSO4 on heating converted into Fe2O3 plus SO2 plus SO3, that is ferrous sulfate on heating converted into ferric oxide plus sulfur dioxide and sulfur trioxide. Here we can see the byproducts are sulfur dioxide and sulfur trioxide. That's why we are getting a smell similar to that of burning of sulfur. And can you observe one thing? A single reactant, that is ferrous sulfate, is decomposed to form 3 different products such as ferric oxide, sulfur dioxide and sulfur trioxide. Such type of chemical reactions are called decomposition reaction. We can say that ferrous sulfate crystals have 7 water molecules in it, that is FeSO4 7H2O. When we heat this, it loses its water molecule and also the color of the crystals changes. It then decomposes into ferric oxide, that is Fe2O3, sulfur dioxide and sulfur trioxide. Here Fe2O3 is a reddish brown solid, whereas sulfur dioxide and sulfur trioxide are gases. Another important decomposition reaction is the decomposition of calcium carbonate. And here you can see the reaction, that is CaCO3 on heating gives CaO plus CO2. Here CaCO3, that is calcium carbonate, is called limestone and the newly formed calcium oxide is called lime or quicklime, and this is used for the manufacture of cement. And we can say that when a decomposition reaction is carried out by heating, it is called thermal decomposition. Let's do an activity to clear the concept of thermal decomposition. For that, here I have 2 grams of lead nitrate powder in a boiling tube. Now, let's heat this boiling tube. What do you observe? Yes, you can see the emission of brown fumes, right? These brown fumes indicate the presence of nitrogen dioxide. And here you can see the chemical reaction, that is 2PbNO3 twice on heating converted into 2PbO plus 4NO2 plus O2, that is lead nitrate on heating converted into lead oxide, nitrogen dioxide and oxygen. Now let's do an activity, that is electrolysis of water. So you tell me, what do you mean by electrolysis? We can say that electrolysis is the process by which electric current is passed through a substance and causes a chemical change. The process is carried out in an electrolytic cell and has positive and negative electrodes held apart and dipped into a solution containing positively and negatively charged ions. Now let's discuss the electrolysis of water. Here you can see a plastic mug which is drilled with 2 holes at its base and fitted with rubber stoppers in these holes. And we can see that the carbon electrodes are inserted in these rubber stoppers. Now let's connect these electrodes to a 6-volt battery. Let's fill the mug with water so that the electrodes are immersed in the water. Also, we can add few drops of dilute sulfuric acid to the water. Now I am taking 2 test tubes and filled with water, and let's invert them over the 2 carbon electrodes. Now I am going to switch on the current and leave the apparatus undisturbed for some time. What do you observe? Yes, we can see the formation of bubbles at both the electrodes, and these bubbles displaces the water in the test tube, right? Here you can see that the positive terminal of the battery is connected to anode and the negative terminal of the battery is connected to cathode. When electricity is passed through water, what is going to happen? Yes, the water split into 2 products, that is hydrogen and oxygen. So we can write it as 2H2O on electricity gives 2H2 plus O2. Here you can see the formation of gases at the test tube. Now you tell me, is the volume of the gases collected is the same on both the test tubes? Here we can see that the volume of gas formed is not same. Cathode has more gas than anode. Now let's test these gases one by one by bringing a burning candle near the mouth of the test tube. What do you observe? Here you can see when we show the candle near the anode, the flame enhances, right? Now let's show the candle near cathode. What do you observe? Yes, the flame decreases. So we can say that at anode, oxygen gas is bubbled and at cathode, hydrogen gas is bubbled. So we can say that in the presence of electricity, water is splitting into hydrogen and oxygen is called electrolysis of water. So friends, let's conclude the experiment that at anode, the gas formed is oxygen, which helps to enhance the flame, and at cathode, the gas formed is hydrogen, which reduces the flame. So friends, let's do another experiment. For that, here is some silver chloride in a china dish. Let's keep it here for some time. What do you observe? See, the white color of silver chloride turns grey in sunlight, right? Why did it happen? We can say that it is due to the decomposition of silver chloride into silver and chlorine by light. Such decomposition is called photodecomposition, which means decomposition taking place in the presence of light. And here is the chemical reaction, that is 2AgCl in the presence of sunlight gives 2Ag plus Cl2, and we can say that silver bromide also reacts in the same manner, and the reaction is 2AgBr in the presence of sunlight gives 2Ag plus Br2, and we can say that these decomposition reactions of silver chloride and silver bromide are used in black and white photography. We have seen that decomposition reactions require energy either in the form of heat, that is thermal decomposition, or light, that is photodecomposition, or electricity, that is electrolysis, for breaking down the reactants. So friends, we can say that reactions in which energy is absorbed is known as endothermic chemical reactions. So can you give me one example for endothermic reaction? Yes, melting of an ice cube is an example for endothermic reaction. Here, ice cubes absorb heat from the surrounding. As a result, ice cubes melt into water. That's why we can say that melting of an ice cube is an example for endothermic reaction. Friends, here I have barium hydroxide in a test tube. To this, we can add ammonium chloride. Now let's mix it thoroughly using a glass rod. Let me touch the bottom of the test tube using my palm. Oh, it's really cold. Why did it become cold? We can say that it is due to the absorption of heat. So we can say this reaction is an endothermic reaction. Now let's discuss some questions. First one is, a solution of a substance X is used for whitewashing. First question is, name the substance X and write its formula. Second question is, write the reaction of the substance X named in the first question and above with water. The answer for first question is, a solution of slaked lime is used for whitewashing walls, and the formula of slaked lime is CaOH twice. And the answer for second question is, the reaction of slaked lime with water, we can see calcium hydroxide dissociate into calcium ions and hydroxide ions. And here is the chemical reaction, that is CaOH twice plus H2O gives Ca2 plus 2OH minus. The second question is, why is the amount of gas collected in one of the test tubes in activity 1.7, that is electrolysis of water, double of the amount collected in the other? And name the gas. The answer is water electrolyzed to give hydrogen gas at cathode and oxygen gas at anode. And the reaction is 2H2O gives 2H2 plus O2. Thus, 2 molecules of water electrolyzed to give 2 molecules of hydrogen gas and 1 molecule of oxygen gas. Or we can say that the amount of hydrogen gas collected would be double than that of oxygen gas. Now let's discuss the third type of chemical reactions, that is displacement reactions. So what do you mean by displacement reactions? We can say that displacement reaction is a chemical reaction in which a more reactive element displaces a less reactive element from its compound. So friends, let's do an activity. Here I have 3 iron nails. Now let's rub it using a sandpaper. And let me take 2 test tubes and let's name this as A and B. Let's fill these test tubes with 10 ml of copper sulfate solution. Now let's immerse these 2 iron nails in the test tube B for 20 minutes. Also, we can keep 1 iron nail aside for comparison. It's been 20 minutes. Now let's take out the iron nails from the copper sulfate solution. So you compare the color of the copper sulfate solutions in the test tube A and B. Also you compare the color of the iron nails kept inside the copper sulfate solution and kept aside for comparison. Here we can see the color of the iron nails dipped in the copper sulfate solution become brownish when compared to the one kept aside for comparison. Also we can see the color of the copper sulfate solution becomes faded. What would be the chemical reaction that happened here? Here is the chemical reaction, that is Fe plus CuSO4 gives FeSO4 plus Cu. Here we can see that iron displaced or removed copper from copper sulfate solution, and this reaction is known as displacement reaction. Here are some more examples of displacement reactions. They are Zn plus CuSO4 gives ZnSO4 plus Cu, and Pb plus CuCl2 gives PbCl2 plus Cu. Here we can see zinc and lead are more reactive than copper, therefore they displaces copper from its compound. How can we say that zinc and lead is more reactive than copper? According to reactivity series, we can see that copper is lower in reactivity series than zinc and lead. Therefore, they can easily displace copper from its compounds. So you tell me, what do you mean by reactivity series? Well, reactivity series is the arrangement of metals in the decreasing order of their reactivities. Now let's do another activity. For that, here I have 3 ml of sodium sulfate and 3 ml of barium chloride in 2 different test tubes. Now let's mix these solutions together. So you tell me, what do you observe here? See, there is a formation of white substance which is insoluble in water, and this insoluble substance is called as a precipitate. So we can say that any reaction that produces a precipitate can be called as a precipitation reaction. Here, sodium sulfate and barium chloride react to form barium sulfate and sodium chloride. And here is the chemical reaction, that is Na2SO4 plus BaCl2 gives BaSO4 plus 2NaCl. Here, the white precipitate of barium sulfate is formed by the reaction of sulfate ion, that is SO4 2- ions, and barium ions, that is Ba2 plus ions. So we can say that such reactions in which there is an exchange of ions between the reactants are called double displacement reactions. Can you give me one more example for double displacement reaction? Do you remember the activity we did using lead nitrate and potassium iodide? We know that when we mix it together, we got yellow precipitate, right? And the reaction is PbNO3 twice plus 2Ki gives PbI2 plus 2KNO3. Here, the yellow colored substance is nothing but lead iodide. Here we can see the exchange of ions between reactants such as lead nitrate and potassium iodide. Therefore, we can say that this is an example for double displacement reaction. Till now, we have discussed the types of chemical reactions. Now let's move on to our next topic, that is oxidation and reduction. See friends, here is copper powder in a china dish. Now let's heat this copper powder. So you tell me, what do you observe here? See, it became black in color. So you tell me how it became black in color? This is because when oxygen is added to copper, it is converted into copper oxide, which is black in color. And here is the chemical reaction, that is 2Cu plus O2 on heating is converted into 2CuO, that is copper oxide. When we pass hydrogen gas over this copper oxide, a reverse reaction will take place and we will get copper, that is CuO plus H2 on heating converted into Cu plus H2O. So, we can say that if a substance gains oxygen during a reaction, it is said to be oxidized. And if a substance loses oxygen during a reaction, it is said to be reduced. For example, let's consider CuO plus H2 on heating gives Cu plus H2O. Here we can see CuO on reduction gives Cu and H2 on oxidation gives H2O. So this is a redox reaction. In other words, we can say that copper oxide is losing oxygen and is being reduced, and the hydrogen is gaining oxygen and is being oxidized. Or we can say that one reactant gets oxidized while the other gets reduced during a reaction. Such reaction is known as oxidation-reduction reaction or redox reactions, in which both oxidation and reduction takes place in a single chemical reaction. Can you give me some other examples of redox reactions? Here are some other examples. First one is ZnO plus C gives Zn plus CO. Here we can see ZnO is reduced into Zn, whereas C is oxidized into CO. And the second reaction is MnO2 plus 4HCl gives MnCl2 plus 2H2O plus Cl2. Here we can see HCl is oxidized into chlorine, whereas MnO2 is reduced into MnCl2. Now let's conclude oxidation reduction once again, that if a substance gains oxygen or loses hydrogen during a reaction, it is said to be oxidized. And if a substance loses oxygen or gains hydrogen during a reaction, it is said to be reduced. Now you tell me, in this reaction of 2Mg plus O2 gives 2MgO, here magnesium is being oxidized or reduced? We can say that here magnesium gains oxygen to form magnesium oxide. Therefore, we can say here magnesium is being oxidized in this reaction. Have you observed the effects of oxidation reactions in everyday life? You must have noticed that objects made of iron are shinier when they are new, but they are coated with a reddish-brown powder when left for some time. This process is commonly known as rusting of iron. And you tell me, how does this happen? We can say that when iron is in contact with moist air for long, it acquires iron oxide, which is responsible for rust. And have you noticed the green color coating formed on copper and silver? We can say that when a metal is attacked by substances around it, such as moisture, acids, it is said to be corrode. And this process is called corrosion. So we can say the black coating on silver and the green coating on copper are other examples of corrosion. Corrosion causes damage to car bodies, bridges, iron railings, ships, and to objects made of metals, especially those of iron. And we can say a lot of money is spent to replace damaged iron. Next, we can discuss rancidity. Have you ever smelled the leftover fat-containing food materials? It's not good, right? So we can say that when fats and oil are oxidized, they become rancid and their smell and taste changes. This is known as rancidity. How can we prevent rancidity? We can say that keeping food in airtight containers helps to slow down oxidation. And also, antioxidants are added to foods containing fats and oil. These are the methods to reduce rancidity. Do you know why chip manufacturers usually flush packets of chips with gases such as nitrogen? It is to prevent the chips from getting oxidized. Through this, we can increase the shelf life of foods. Now let's discuss some questions. First question is, why does the color of copper sulfate solution change when an iron nail is dipped in it? The answer is iron present in iron nails displaced or removed copper from copper sulfate solution. This reaction is known as displacement reaction. As a result of displacement reaction, the color of copper sulfate solution changes. The next question is, give an example of double displacement reaction. So we can write it as PbNO3 twice plus 2Ki gives PbI2 plus 2KNO3. Here we can see the lead nitrate react with potassium iodide to form lead iodide and potassium nitrate. This is the best example for double displacement reactions. Next question is, identify the substances that are oxidized and the substances that are reduced in the following reactions. First reaction is 4Na plus O2 gives 2Na2O, and the second reaction is CuO plus H2 gives Cu plus H2O. We know that if a substance gains oxygen during a reaction, it is said to be oxidized, and if a substance loses oxygen during a reaction, it is said to be reduced. Therefore, we can say that in the first reaction, sodium is oxidized into Na2O, and in the second reaction, CuO is reduced into Cu and H2 is oxidized into H2O. So friends, here ends our first chapter, that is chemical reactions and equations. So we focus on the topics we learned. Keep learning and stay safe.